All right, so we have a bolt that falls off of a roof, okay, that is 6 meters above the ground. We're looking for how long it'll fall. All right, does it seem like this question gives me very much information? Okay, only gives me one number, but okay, that's fine. There are actually other numbers that are sort of hidden in the question. Something falls off of a roof. How fast was it going initially? No? Zero. Yeah, it had an initial velocity of zero if it fell off. It wasn't thrown off, okay, or projected off in any way. All right, it just fell. So our initial velocity is 0 meters per second. We know that the distance it's going to fall is 6 meters. And at what rate will it fall? 9.81 meters per second squared. All right, so sometimes you have to read into a question a little bit. Actually, I'm going to make them all positive because they're all down. Okay, so 9.81 meters per second squared. All right, so I'm looking for how long it will fall for. Okay, what formula am I going to use here? That's right. Okay, I'm going to use this one. And remember how I said you'd have to do factoring to solve for t? Except that you don't on this one because VI is 0, which really just means that d equals 1/2 AT squared. All right, so I'm just solving for t, so I'm going to divide both sides by half of a. And then what? I'm looking for t, not t squared, so I need to square root. All right, so I put in the square root of 6 over 1/2 times 9.81, and that'll equal t. Okay, so square root of 6 divided by 4.905. That's half of 9.81. All right, it's going to fall for 1.1 seconds. All right, everybody okay with that? Okay, really, guys, acceleration problems are not very difficult. Okay, we just have to establish what the givens are, figure out what formula we're using, sometimes manipulate that formula, and we're done. Okay, it's just a matter of, can we handle the algebra? Can we handle the manipulation of the formula? That's the trickiest part, okay, of doing an acceleration problem. And if you're in physics 20, manipulation shouldn't be too much of a problem for you because, well, you're going to do tons and tons of it. That's basically all the math we ever do in this course. Okay, try this one. So on this one, we're looking for the final velocity. We know the distance over which the object is accelerated. It's 0.3 meters. Okay, and the acceleration of the object is 22 meters per second squared, and the time over which it accelerates is 0.72 seconds. All right, so which formula am I going to use if I've got those four things, or those three things looking for VF? Right, VF times T minus 1/2 AT squared is the formula I'm going to want to use here. All right, if I'm going to get VF by itself, what should I move first? Right, I want to move this whole thing over to this side by doing what? Adding it, right? And I'm subtracting that term, so I'm going to add it over to the other side. So I'm going to have D plus 1/2 AT squared equals VF times T. All right, then I just need to get T over to the other side by dividing it. Okay, and remember we talked about this the other day. Those T's don't cancel. All right, we have to enter everything in as it appears here. All right, so we're going to have 0.3 meters plus 1/2 times 22 times 0.72 squared divided by 0.72. All right, so we're looking at 8.3 meters per second. Okay, we weren't given a vector in that question, so we have to leave it at that. Okay, questions on that one? All right, how are we feeling about the manipulations here, about the algebra of this? All right, the reason we're going over all this algebra, guys, is because you have to do a bunch of acceleration manipulations when we do projectile motion, because a projectile is always accelerating due to gravity. So acceleration is a big part of projectile motion. All right, give this one a try. See if you can handle it. Okay, so in this one, we're looking for the initial velocity of a bullet. Okay, so that's our question mark. Okay, that enters ballistics gel. So if you ever watch like Mythbusters, they make like those things that look like they're made out of jello. Okay, it's called ballistics gel. It actually has the same consistency as the human body. Okay, that way they can kind of tell how much damage can be done, okay, based on various things. Okay, so it enters ballistics gel and slows at 150 meters per second squared. Okay, for 0.252 seconds. Okay. Its final velocity is 65.2 meters per second. All right, so can we use our old science 10 formula for this one? Yeah, okay, we've got enough information for that. Okay, so A equals VF minus VI over T, and we are trying to solve for VI. So I'm going to multiply both sides by T first, and then I'm going to add VI over to this side, so I'm not solving for a negative number. Okay, then what am I going to do with T times A? Right now I'm adding T times A, so I want to subtract T times A. So VI will equal VF minus T times A. This was one of the ones that was on our quiz yesterday. Okay, one of the manipulations we had to do. Okay, here's the way we need to look at this. T times A equals VF minus VI. So in other words, T times A equals the change in velocity. Right? So if I take the final velocity and subtract the change, that should leave me with what I started with. Everyone kind of follow that logic? Okay. Similarly, if I was looking for VF, okay, it would be the initial plus the change. That would give me VF. Everyone okay with that logic there? Okay. All right, so when we do this one here, we're going to plug in. We got 65.2 minus 0.252 seconds times negative 150 meters per second squared. Why do I have to make it negative? It's slowing down. Okay. It's the only way I'll get a VI that's bigger than VF. This is another one of those questions where when you get your answer, it needs to make sense within the context of the question. If you make this positive, it tells you that VI was less than VF, which is impossible in this situation. Okay. All right, so it was moving at 103 meters per second, okay, when it hit the ballistics gel. Everybody all right with that one? Okay. I'm going to have you guys try a few out of the digital workbook now, okay, just kind of working through them. You don't necessarily have to do them in order. If you want to kind of pick some at random from the sheet and try a few, that's probably better, because I think I made it go in order where like the first four are all the same formula and the second four are all the same formula, so you might want to just kind of pick a few at random and see how you do on there. The answers are on there, so you can check them as you go. Okay, so we are looking at starting on the very bottom of page 5, okay, and the top of page 6. I would say let's just skip number 1 and okay, we start there, okay. It's a whole bunch of different kinds of questions. Some of them involve the graph, okay, some don't, but they give you a pretty good idea of the types of things I'm going to ask when it comes to acceleration problems. All right, I'll give you a few minutes on those, and then we'll see if we need to go over any. If you got any questions, just ask.